Welcome to today's webinar on the Extreme Heat Events module produced by the Minnesota Department of Health. I'm Michaela Rush, a health educator and communications specialist with the Climate and Health Program at the Minnesota Department of Health. The Minnesota Climate and Health Program is part of a nationwide effort to anticipate, prepare for, and respond to health impacts of climate change. The program follows 5 overarching goals that guide its work. Educate and increase awareness of the health impacts of climate change, research and improve data for research to ensure that our work is based on the best science available, design and evaluate adaptation interventions, develop tools and products for public health practitioners and others to use to prepare for climate change, and provide technical assistance to communities for mapping vulnerable populations and planning for climate changes. This training module is one of 6 training modules that address the health effects of climate changes in Minnesota. The other 5 training modules cover the topics of Climate and Health 101, Agriculture and Food Security, Water Quality and Quantity, Air Quality, and Well-being. These modules have been designed for public health professionals as well as others concerned about climate change to provide a basic level of information about the observed climate changes in Minnesota and their health impacts. Each module is a set of slides scripted with slide notes, so you can present them to your own audiences. We are sharing the other 4 training modules with monthly webinars through December of this year. Following each webinar, we will post the training module on the Minnesota Department of Health website so anyone can access it for future use. These training modules are funded in part by a grant for the Centers for Disease Control and Prevention. Today's webinar will be interactive. We will be asking 3 polling questions throughout the session that you can respond to using the polling bar that will appear on the right side of your screen. If you have any questions throughout the session, please submit them using the chat function located in the drop-down on the top of your screen. We will be saving 15 minutes at the end to answer them. I would now like to introduce our presenter for today's webinar, Dr. Brenda Hoppe. Dr. Hoppe is a research scientist with the Minnesota Department of Health Climate and Health Program, where she studies climate change impacts on the health and well-being of Minnesotans. She also assists with developing climate adaptation strategies for communities across the state. Her current research interests include modeling future impacts on drinking water from extreme rainfall, advancing climate and health vulnerability assessments, and developing methods for using climate projection data in public health. She earned her doctorate in environmental public health and toxicology from Oregon State University and a master's in human physiology at the University of Oregon. In her free time, Dr. Hoppe chairs the Midwest Skateboarding Alliance, which advocates for skateboarding as a component to building healthy communities and individuals. Welcome, Dr. Hoppe.
Great, thanks, Michaela. And thanks to all of you for tuning in today. For this webinar on extreme heat, we'll be covering a number of topics, including climate changes in Minnesota, extreme heat events and their association with climate change, urban heat island effect, human health impacts from extreme heat and identifying vulnerable populations, and then strategies aimed at both public health professionals as well as members of the public. So the first section covers climate changes in Minnesota. Although related, the terms weather and climate are actually defined differently. Weather generally refers to conditions of the atmosphere that occur over a relatively short period of time, on the order of days to weeks, while climate refers to conditions of the atmosphere that occur over much longer periods of time, on the order of decades. Often, climate assessments will take into account at least 3 decades of data. Climate change refers to any significant variations in the climate that last for at least several decades. Weather has always fascinated Minnesotans, probably because we have all kinds of it and a lot of it's extreme, but recently climate change has become a leading topic of concern in our state. Actions to prevent the damaging effects of climate change are often described as either adaptation or mitigation efforts. Adapting to climate change means anticipating and preparing for the effects of climate change to reduce any related damage. Mitigating climate change means taking on or supporting efforts that slow or stabilize climate change by reducing greenhouse gas emissions. MDH's Minnesota Climate and Health Program is dedicated to understanding the links between climate changes and health impacts and identifying opportunities for implementing adaptation strategies in Minnesota communities. Climate change in Minnesota is resulting in warmer temperatures and changing precipitation patterns. Climate scientists attribute these changes to burning of fossil fuels like coal and oil to produce energy for our everyday use. This burning adds heat-trapping gases like carbon dioxide into our atmosphere. These gases are referred to as greenhouse gases. As the graphic shows, the rise in greenhouse gas emissions is leading to increases in temperature and changes in our historical precipitation patterns. These changes are then impacting air quality, weather patterns, water quality and quantity, and ecosystems, which in turn are leading to more air pollution, extreme heat events, flooding and drought, and ecosystem threats like Lyme disease and West Nile virus. Minnesota has become noticeably warmer, especially over the last few decades. Since the beginning of the data record around 1895 through the mid-20th century, Minnesota's annual average temperature increased by nearly 0.2 degrees Fahrenheit per decade. This is shown on the graph to the left. This warming effect has sped up considerably over the last 50 years. Data from 1960 to 2016 show that the recent rate of warming is over 0.5 degrees Fahrenheit per decade. Let's pause for a polling question.
Okay, we will now be having our first polling question. Based on more than a century of data, how many of the top 10 warmest years for Minnesota do you think occurred within just the last 3 decades? 3, 5, or 9? You will have 10 more seconds to respond. Thank you for answering. 9 of the top 10 warmest years for Minnesota occurred within just the last 3 decades.
Great, thanks, Michaela. The rising temperature trend is driving changes in Minnesota's environment, affecting ice cover, soil moisture, bird migrations, insect behavior, and forest and plant growth. Some of these changes will certainly impact the health and well-being of Minnesotans. For example, finding ways to cope with recent summer heat waves has made climate change much less of an abstract concept for many residents, especially those who struggle to acclimate or adjust to these events, and the challenge will likely increase. Based on more than a century of data, some of you may have guessed 9 of the top 10 warmest years for Minnesota, shown in the slide as the peaks with red points, have occurred just within the last 3 decades. Within this overall warming trend, there have been 3 significant observations in Minnesota. First, winter temperatures are rising twice as fast as the annual average temperatures. We are now experiencing warmer winter temperatures, less snow, and more winter rain, and changes in the amount and timing of ice on our lakes. Second, minimum temperatures, which are often referred to as our overnight lows, have been rising faster than maximum temperatures, which are the daytime highs. In just the last 30 years, average annual overnight lows have been rising at a rate of 0.6 degrees Fahrenheit per decade. And lastly, the northern part of the state is warming faster than the southern part. Over the last 30 years, there's been a distinct spread of warmer overnight lows into the northern half of Minnesota. And this is consistent with patterns seen across the northern hemisphere, where climate changes are occurring more rapidly at higher latitudes. The change in temperature is already causing substantial shifts in the environment. The U.S. Department of Agriculture develops maps identifying plant hardiness zones, which show what types of plants will survive well and where. The zones provide a standard by which gardeners and growers determine which plants are most likely to thrive at a certain location. Zones are based on the average yearly minimum winter temperature over a 30-year period. This figure from the National Arbor Day Foundation compares past zones with the present. In 1990, Minnesota was predominantly Zone 3 in the northern half of the state and Zone 4 in the southern half. In 2015, these zones shift north substantially, and in fact, plant hardiness zones historically associated with areas like southern Iowa, Illinois, and areas far west of the Rockies have now arrived in southern Minnesota. These shifts, while allowing for new species to thrive in Minnesota, will also stress native plant species and may make it easier for non-native plants and the insects and pathogens that rely on them to move into areas where they previously couldn't survive. With a warming atmosphere, more evaporation occurs. Warm air is less dense than cold air, and so there's more room for water vapor in warmer air than cold. The water holding capacity of air increases by about 7% per 1 degree Celsius warming, which is equivalent to about 34 degrees Fahrenheit. That's why our summers are more humid than our winters and why summer storms can release a lot of rain. The chart on this slide shows Minnesota's average yearly precipitation from 1895 to 2016. For most of the first half of the 20th century, the trend in precipitation was slightly downward at a loss of about 0.2 inches per decade. However, in the last 50 years, the rate of precipitation across the state has increased by nearly ½ of an inch per decade. Overall, our average yearly rainfall is increasing, and this increase is being driven by heavy precipitation events. This timeline captures the historic mega rain events in Minnesota that have occurred since the middle of the 19th century. A mega rain event is defined as a 6-inch rainfall that covers more than 1,000 square miles, with the core of the event topping 8 inches. So we're talking about rare but highly significant events. 15 mega rain events have occurred in Minnesota since 1858, with 7 of these events having occurred just in the last 15 years. A recent study of precipitation in Minnesota found that storms with 3 inches or more rainfall have increased by more than 100% over the last 50 years. So it's not just the amount of precipitation that's increasing, but the patterns and character of this precipitation that's dramatically changing, opening up the possibility for longer, drier periods in between these heavy localized rain events, leaving some areas of the state drenched and others in drought-like conditions. For example, in 2012, 75 counties were declared primary or proximal disaster areas for drought. However, in that same year, 15 counties and 3 tribal reservations were declared disaster areas for flooding, with 8 counties receiving disaster designation for both in that same year. Humidity is a function of both temperature and water vapor in the atmosphere. Health professionals are particularly interested in humidity since this affects the skin's ability to evaporate moisture and cool the body. Dew point is a measure of water vapor in the air. Specifically, dew point is the temperature at which water vapor in the air will begin condensing to form dew on the grass or fog in the air. The higher the dew point, the more uncomfortable and physically stressed a person will feel. This is because the body cools itself by sweating. And if the dew point is high, it becomes more difficult for sweat to evaporate off the skin. When the dew point rises above 65 degrees, that's when folks will complain about it feeling sticky outside. Based on historical data, yearly maximum dew point temperatures are increasing in Minnesota. This trend is modest but significant. We are also experiencing an increase in the frequency of dew point readings at or above 75 degrees, a level that is very uncomfortable and even potentially dangerous for vulnerable individuals. In fact, the frequency of these extreme dew point temperatures is 51% more common in the last 50 years compared to the first half of the last century. Now let's talk more in depth about climate change and concerns about extreme heat. Climate change is causing a shift in the probability of both average and extreme temperatures. Scientists expect climate change to lead to longer, more severe, and more frequent extreme heat events by shifting the historical distribution of average yearly temperatures further to the right. Hot days and heat waves that once were considered rare and record-breaking in Minnesota may now become more common. There is no universal definition of an extreme heat event, given that the experience of heat is dependent on how well an individual or a population is accustomed to high temperatures. Summer temperatures considered commonplace in some place like Phoenix, Arizona, will seem pretty extreme to people living on the North Shore of Lake Superior. In general, most definitions of an extreme heat event refer to an extended period of time with unusually hot weather conditions for that particular time of year. Many weather stations rely on the calculation of the heat index to communicate heat risk. The heat index is a measure of how hot it really feels when relative humidity is factored in with the actual air temperature. For example, if the air temperature is 88 degrees and the relative humidity is 80%, the heat index, or rather how hot it actually feels to the average person, is 106 degrees. The red area on the chart indicates extreme danger. Keep in mind that heat index values are derived assuming shady, light wind conditions. Exposure to full sun can add 15 degrees to a heat index value. Furthermore, strong winds with very hot, dry air can significantly increase the risk of a hot day. This map shows the service area for the 6 National Weather Service stations serving Minnesota. Each station releases heat alerts and warnings depending on the weather in its service area. In general, the National Weather Service issues the following heat-related communications depending on severity. Excessive heat outlooks are issued when there is the potential for an extreme heat event in the next 3 to 7 days. Excessive heat watches are issued when conditions are favorable for an extreme heat event in the next 24 to 72 hours. Heat advisories are issued within 12 hours of an expected heat event. In general, an advisory is issued when the maximum heat index is expected to reach or exceed 100 degrees for at least 2 days, and the nighttime air temperature is not expected to drop below 75 degrees. Excessive heat warnings are issued within 12 hours of an extremely dangerous heat event. Generally, a warning is issued when the maximum heat index is expected to reach or exceed 105 for at least 2 days, and nighttime air temperature, again, is not expected to drop below 75. That advisories and warnings take into account the lack of nighttime cooling underscores how important this cooling is for the body. The drop in overnight temperatures gives relief to people who lack air conditioning or access to cool spaces. Elevated nighttime temperatures can continue to stress the body, prolonging the physical strain and increasing risk for serious injury. 2011 was a standout year for heat in Minnesota. That year, there were 5 extreme heat events worthy of issuing heat advisories or warnings. On July 19, 2011, heat indices reached record levels across the state. The Twin Cities experienced a record heat index of 119 degrees for the metro area, while the state record was broken in Moorhead, where the heat index topped off at 130 degrees. The Minnesota Weather Almanac by Dr. Mark Seeley is the 200-year weather history of the state. Minnesota has experienced many heat waves over the years, as listed here on the slide. The ones noted in purple were driven by high dew points, not high air temperatures. You can see a clear trend of recent extreme heat events driven by high dew point temperatures, whereas past extreme heat events were driven by high air temperatures. And this trend will likely continue if high dew point temperatures continue to occur. Given the rise in maximum dew point temperatures, the rise in overnight low temperatures, and the overall warming trends seen across the state, Minnesotans should be prepared for more extreme heat events. Next, we'll cover the urban heat island effect, which can increase the health risk for people living in urban areas. The urban heat island effect refers to a measurable increase in urban air temperatures, resulting primarily from the replacement of green spaces with buildings, roads, and other heat-absorbing infrastructure and materials. The heat island effect can result in significant temperature differences between rural and urban areas. The effect is proportional to the size of the city, but all cities, large and small, have urban heat islands. So let's take a break for another polling question.
On average, a city with 1 million people can be nearly 2 to 5 degrees warmer than a nearby rural area during the day. What do you think the difference can reach in the evening? 2 degrees, 12 degrees, or 22 degrees? You will have 10 more seconds to submit your response. Thank you for answering. In the evening, the difference can be as high as 22 degrees.
There are many consequences of the urban heat island effect, but the cost associated with countering high temperatures in urban areas is especially significant. The chart on this slide shows that even a small increase in temperature during already peak periods can cost hundreds of millions of additional dollars in increased electricity costs for air conditioning. As you'd expect, the Twin Cities metro area has not one but multiple urban heat islands. And as you can see in the figure, they are not just limited to the downtown corridor. An extensive research effort led by University of Minnesota researchers Peter Snyder and Tracy Twine is characterizing the various factors that contribute to urban heat islands, developing models to assess intervention strategies, and applying select strategies to the Twin Cities area. 3 strategies to reduce the urban heat island effect are green roofs, cool roofs, and permeable pavements. A green roof, sometimes called a living roof or eco roof, is a layer of vegetation grown on a rooftop. Green roofs provide shade and remove heat from the air through evaporation and transpiration from plants, reducing temperatures of the roof surface and the surrounding air. The Target Center in downtown Minneapolis was the first arena in North America to be covered in a green roof. At 2.5 acres, it's the largest green roof in Minnesota. A cool roof is made of highly reflective materials that emit sunlight and heat away from the building. A cool roof can stay approximately 50 to 60 degrees cooler than a traditional roof during peak summer weather, with energy savings averaging around 20%. Permeable pavements were originally designed for stormwater control, but have emerged as a potential for reducing urban heat. Permeable pavement allows both air and water to pass through the material. When wet, these pavement materials can lower air temperatures through evaporative cooling, drawing heat out of the pavement, similar to what occurs with green roofs. In the next section, we'll describe the human health impacts related to extreme heat events and identify those populations that are more vulnerable or have characteristics that make them more at risk for extreme heat events. Heat stress and heat-related illness are the primary health concerns associated with high heat days. To function best, the body needs to maintain a core temperature within a narrow range around 98.6 degrees. When core temperature rises, the body's response is to sweat and circulate blood closer to the skin's surface to increase cooling. If heat exposure exceeds the body's cooling capacity and core temperature rises, then a range of symptoms and conditions can develop. These symptoms can begin with relatively minor treatable conditions such as muscle cramping, dizziness and fainting, and swelling in the ankles, feet, and hands. These symptoms can escalate, sometimes quickly, to a condition of heat exhaustion, with symptoms of profuse sweating, weakness, rapid breathing, dizziness, nausea, muscle cramps, and headaches that result from extreme depletion of blood plasma and requires immediate treatment. Without treatment, heat exhaustion can lead to heat stroke. Heat stroke is an extreme medical emergency and often occurs when core body temperature rises above 104 degrees, which can damage vital organs like the brain and kidneys, leading to permanent neurological effects and even death. Just 6 degrees increase in core body temperature from 98.6 to 104 degrees, and the human body loses its ability to adjust and cope with extreme heat. An analogy can be made here between the human body and our planet. Some people interpret the observed increases in ambient temperatures as being perhaps small and insignificant, but just like the body, our atmosphere and ecosystems function within a tight, set, optimal range. When pushed to the ends of this range, natural systems can adjust and adapt. However, as warming increases and becomes more severe, the coping capacity of the human body gives way to dangerous outcomes. Likewise, we are seeing evidence that our planet and its attendant natural systems impacted by the recent rate of warming are showing numerous signs of adverse change. The Centers for Disease Control and Prevention estimates that over 7,000 heat-related deaths occurred in the U.S. from 1999 to 2009. As an example of the impact potential from extreme heat events, more than 700 deaths were attributed to the 1995 Chicago heat wave, which has become a seminal public health tragedy which we continue to learn from today. Just as an aside, to learn more about the Chicago heat wave and the numerous social and environmental factors that contribute to the danger of heat waves, I highly recommend Eric Kleinenberg's book titled Heat Wave, A Social Autopsy of Disaster in Chicago. This figure shows the average annual death rate attributed to excess heat exposure for the U.S. While total death counts for ages 85 and older drops off, death rate is highest in this age group due to smaller population numbers as well as their increased vulnerability. Vulnerability to heat in our later years occurs because of changes in our body's thermoregulatory system, but it can also occur because of social isolation and other factors. Everyone can suffer serious impacts from exposure to high heat, but some populations are particularly vulnerable. These populations include the elderly, children under 5, individuals with certain pre-existing health conditions like respiratory, cardiovascular, or metabolic diseases, people taking certain medications like diuretic, anticholinergics, and psychotropic drugs, and finally athletes, outdoor workers, and displaced individuals without reliable shelter. So let's pause for one more polling question.
We will now be having our final polling question. After learning about at-risk populations for extreme heat, which population do you think has the highest rate of emergency department visits due to heat-related illness? Children ages 0 to 4, men ages 15 to 34, or women ages 65 plus? You will have 10 more seconds to submit your response. Thank you for answering. The correct answer is men ages 15 to 34. Let's learn why.
Thanks, Michaela. Limited data from Minnesota show that men ages 15 to 34 years old represent the highest numbers of emergency department visits due to heat-related illness, more than any other sex or age category. This is likely due to increased exposure to heat because of outdoor occupations and exercising outdoors. However, it should be noted that this data set includes only cases that were specifically coded for heat-related illness, perhaps representing the most obvious and extreme cases. Often, heat exposure is a major factor in aggravating a pre-existing condition or triggering a dangerous reaction. but it may not be recorded as such in the diagnosis code or intake records from the clinic or hospital. Heat-related exposure is widely recognized as being underreported as a primary or even contributing condition for emergency department visits, hospitalizations, or fatalities. Factors that can contribute to a person's susceptibility or vulnerability to extreme heat include a lack of air conditioning, living alone or lacking tight social or family ties, disability or illness that confine an individual to their room or their apartment, living in the topmost floor of a building, given that warm air rises and there is no overshading that lower floors benefit from, living in urban areas due to the urban heat island effect, and finally, low socioeconomic status. Now, as we wrap up, we'll cover strategies that public health professionals and individuals can use to prevent heat-related illness. The most highly promoted strategy to address extreme heat for public health professionals involves developing and acting on a heat response plan. These plans describe in detail the roles and actions of government agencies and non-governmental organizations for preventing morbidity and mortality from an extreme heat event. Each city or county in Minnesota should have a heat response plan. Sometimes heat response plans are added as an annex or supplement to local all-hazard plans. The level of detail and the number of strategies in the plan will vary based on available resources, location, agencies and organizations involved in planning and responding, and the vulnerable populations that are served. The key is to develop heat response plans well before an extreme heat event occurs. Having a written response plan is not enough, however. It's critical for the lead agency to develop partnerships with the National Weather Service to ensure access to early weather forecasts. All Minnesota jurisdictions involved in planning and implementing heat response plans should develop relationships with their local National Weather Station to ensure communications on daily monitoring of weather conditions, particularly during warm season months. Once the lead agency is informed of a possible extreme heat event, the agency, in collaboration with its partners, needs to determine if the forecast is indicative of an extreme heat event that should trigger activities of the heat response plan. Then the public needs to be informed of the timing, severity, and duration of the forecasted event, along with strategies to stay cool and hydrated and places to go to cool off. Finally, each step of responding to an extreme heat event should be reviewed and evaluated after the event. This evaluation is critical for improving the plan and making it more effective for preventing future heat-related illnesses and mortalities. The Minnesota Climate and Health Program has developed resources to help with planning and addressing extreme heat events. For more detailed information on developing and implementing heat response plans for your jurisdiction, particularly in Minnesota, a good place to start is our Minnesota Extreme Heat Toolkit and Extreme Heat Tip Sheet, and both are available for download on our website. Quantifying and mapping vulnerable populations and other risk factors are crucial activities for planning and implementing appropriate strategies that reach the most vulnerable members of a community. The lead response agency or another entity should create data summaries and maps to identify the most vulnerable populations in their community and where the populations reside, so that appropriate preventive actions and strategies for these populations can be determined before an extreme heat event. In 2014, the Minnesota Climate and Health Program released the state's Climate Change Vulnerability Assessment. Here and on our website, you can find statewide maps of vulnerable populations and data sources for risk factors related to extreme heat. You can find other resources through our website as well. Here is a graphic developed by MDH to educate the public on recognizing the signs of heat exhaustion and heat stroke. This is also available for professional and public use on our website. Actions that anyone can take to protect themselves and their families on very hot days include, first and foremost, staying hydrated. Drink plenty of fluids and avoid drinks that are high in sugar or alcohol. Obviously, stay cool. Try to keep to indoor, air-conditioned places and wear lightweight, loose-fitting clothing. If you have to be outside, schedule outdoor activities carefully. Take time to adjust to the heat and pace yourself. Check on people that may be at more risk to the heat. Check on elderly or ailing neighbors, and do not leave children or pets in cars. Finally, stay informed. Keep up with the local news for daily weather forecasts, and of course, look to your local public health departments for health and safety information. Finally, before we wrap up, we wouldn't be doing our due diligence as a climate and health program if we didn't discuss what all of us as individuals can do to address climate change. The next few slides list actions each of us can take to make a difference. First, energy production is one of the big three contributors to our changing climate because burning oil, coal, and natural gas to generate electric power puts a lot of greenhouse gas emissions into the air. As individuals, we can each reduce the amount of greenhouse gas emissions that we cause in a number of ways, like using less energy to heat or cool homes, using energy-efficient appliances and light bulbs, and reducing, reusing, and recycling products that we buy and use on a daily basis. However, what is really going to make a difference is having all of us rely more on renewable energy sources like solar, wind, and biofuels, and less on fossil fuel energy sources like oil, coal, and natural gas. As individuals, we can support public and private sector policy changes that lead to more renewable energy production. One policy example is Minnesota's Next Generation Energy Act of 2007 that identifies achievable greenhouse gas emission reduction targets for the state by 2025 and beyond. Transportation is the second big contributor to our changing climate because burning fuel to power vehicles emits a lot of greenhouse gas emissions into the air. As individuals, we can each reduce the amount of emissions that we cause by using transportation choices that burn less gasoline or diesel fuel, like walking, biking, using public transit, carpooling, and telecommuting when possible, or driving an electric vehicle. In addition, we can support public and private sector policies like increasing gas and diesel mileage standards, incentivizing the production and purchase of electric vehicles, building more transit options where population density exists, and having policies that support telecommuting. Agriculture is the third big contributor to greenhouse gas emissions because it takes a lot of energy to produce, process, and transport our food. As individuals, we can each reduce the amount of greenhouse gas emissions that we cause by buying more locally grown foods, eating fewer processed foods and less meat, and even growing some of our own food. However, what is really going to make a difference is if we all have access to foods that are produced, processed, and transported using less energy. We can support public and private sector policies that incentivize foods produced with fewer chemicals, foods that are less processed, and foods that are transported shorter distances. Finally, in summary, Minnesota's climate has become warmer and more humid. Minnesota may experience more frequent and intense extreme heat events, and as a result, higher morbidity and mortality due to heat-related illness. Certain populations are more vulnerable to environmental heat. And as public health practitioners, we need to be aware of where those populations are located and committed to reducing the risk to extreme heat for these citizens. The Minnesota Climate and Health Program has also created a 2-page summary sheet for this training module, providing a brief overview of the topics that we discussed today. It is also available on our website. Here are some additional resources for more information on extreme heat, climate change, and public health issues, also available on our website. And that's all I have today. Thank you so much for tuning in, and I would be delighted to hear any questions that you may have.